Hi, welcome back to the Introduction to Basic Unix as part of the Bioinformatics Virtual Coordination Network. We are walking through the Happy Belly Bioinformatics tutorial on Unix. This is lesson 3. Lessons 1 and 2 are in the are below in the description of this video. We will be working in the binder environment that's associated with this tutorial. That can be found in lesson 1. And so if you have any, and if there's any problems, start with lesson 1 and then return back here to lesson 3. So in this particular lesson, we're going to talk about redirection and redirectors, wildcards, and then how to use history to get some of the information that we might have used, to capture commands that we might have used in the past and want to talk about or keep track of in the future. So like always, we're going to make sure that everybody starts in the same position. This might not be necessary for you, but we can do CD tilde to use our absolute path from home to go into Unix intro. And then we are there. Hit ls to confirm that. Oop, there's our samples underscore dot names remaining from lesson 2. So the first thing that we're going to talk about are these are things called redirectors, and specifically a redirector called pipe. And so pipe is this vertical line on a standard QWERTY keyboard. It's the shift option for the backslash button above your return key. So it's something that you might not have used that frequently. I know I hadn't until I started using this. And so what pipe does is it takes our output, that might be our standard output that we're used to getting, and takes that output and actually redirects it somewhere else. And so the example that we're going to use is we're going to walk through using word count, and specifically word count dash line to count how many lines that we're counting, to use this as our example. And so we've used this before. We can do word count dash line example dot text. When we do that, it says there's 100 lines in there. That might not be the best of what we're looking for. If we hit ls, we see that there are 1, 2, 3, 4, 5 components in our current working directory. And so what we can do is we can actually combine this information. We can say ls pipe. So again, that's that vertical button. That's the shift button of the backspace button, word count dash line. So instead of ls printing out information to the screen here, we can actually do ls pipe and have it go through word count. And so some guesses to what this might be. What we're going to do is we're going to print out how many components are actually present in the directory we're working with. Okay, great. You're like, that's super, super simple. Why would I need that information? Glad you asked. So one of the things that we can do is there's a directory with some files that we're specifically interested in working with in the data directory. So we can do ls data. And then in this case, we're going to look into the subdirectory all files, and we're going to hit enter. And I would just hold on for this. So you can see there's a ton of files. It's a lot, so much that it went off the screen here, and it might make counting them pretty difficult, right? But we might need that information. And so what we can do, and this is one of the things in Unix that can be pretty useful, is we can hit the up button, which will bring up our last command, this ls data all directories, right? And instead of having it print to screen, we can have it use the pipe to have it print using word count dash line. So if I hit enter, there are 900 files in this directory that we're looking at. Okay, that's a lot. That's an interesting amount of information, and we'll come back to that and what we can do with that going forward. The other thing that we want to introduce, or I want to introduce, is instead of a pipe, which is going to string together multiple commands, is this redirect that actually allows us to redirect the output that we're generating into a file, right? So in ls, that's where we are. We're in our Unix underscore intro directory. We have our 5 starting files here. Let me hit clear to start scratch here. So we have our 5 starting components here. If we do ls and then use the caret here to redirect that ls output into something called directory underscore contents.txt. ls does no longer prints that information to the screen, and now prints it into the file that we gave it, right? So we can actually say ls, here's a new file, okay? And if we do head directory contents, we can see what we've done is taken the components of our original directory, so these 5 components here, and we've now put them, including the name that we were looking for, into this file, right? So we've now taken, we've redirected the information that was being printed to our screen and putting it into a file itself. So it is important to know that the redirect will overwrite files that you're pointing to if they already exist. So in this example, we'll do ls experiment, which has the files from lessons 2 and the starting file notes.txt. And so we do ls experiment and then tell it to go into directory contents. This is going to overwrite the directory contents that we had in there originally, right? So this information here will disappear and we'll have a new directory contents with new information. So we can hit enter, head, directory contents. And now instead of the components that were here, it's just the 2 components that were present in experiment. If we wanted to do something different, instead of taking the output and erasing or creating a new file, we can actually take the output and add it to a new file by using 2 carets. And so we'll do this in a similar format. So here right now we have head directory contents.txt. This is the directory contents of experiment. We're here in our Unix intro directory. So if we do ls and then 2 carets and send it towards directory contents, now what we can do, what we've done is instead of replacing directory contents, we've now taken the contents that we're generating, so this ls command, which would have had these 6 elements, and we've added it to these 2 here. And we can prove that with head. And now we have the 2 components that were part of experiment here, and then the 6 components that were part of the directory Unix intro here. And so this is incredibly useful and powerful. There are lots of ways that we might want to interact with this. We'll introduce in lessons 4 and 5, other ways that you can interact with files. And so you can take subsets of files using other Unix commands and write them into new files, or take multiple files and write them in, and append them to something new or something that exists already to make sure that you're storing and capturing the contents that you want. And so this is particularly powerful and will be something that you'll see very regularly with people who are working in the Unix environments. So we can talk a little bit about the wildcards. And so there are a number of wildcards that our Unix has as part of its built-in component. We're going to talk about 2 of them, the asterisk and the question mark. Okay, so we are going to use the asterisk. The asterisk functions as a way of saying, basically, asking this question of, is there anything that has any amount of information that exists related to what I'm asking you to look with it related to, right? So we can do this thing where we do ls. There are currently 1, 2, 3 files in this directory that end with txt. So if we do ls asterisk.txt, it's going to say find anything that has any letters or any components that include .txt at the end of it. And so if we hit enter, what it will return to us is our 3 text files that are here with the .txt output. This can also function with something that includes 0 times, right? So if there was a file incorrectly named .txt and we did this ls, it would also be generated and give us back that information because the 0 counts as anything in that scenario. So we can use this, and we'll use this in this example, using the large number of files that we were working with, or we saw very briefly a second ago in that data all samples file. Okay, so we're going to cd into data and then continue into all samples. And so I can do this. This is a little little brief detour here. I can do this in 2 steps if I wanted to. So I can do CD into data. If I ls, there's some components in here already. These example texts that came from lesson 2. And then CD into all samples. And then I can also, and so I'm going to step back once. I'm going to step back twice. I'm back here in Unix intro. And I can also do it all at once, which is what the example gives us. Right, so I can string these components together to get to exactly where I want to be. I'm going to hit clear so we can start at the start again, except that when I do this, you'll see very quickly, I'm going to hit ls, and we're going to print all of the names of the files in this directory to the screen again. And hit clear to get to the top. I'm going to do ls, and then pipe it to word count -line. And so we've done this just previously, which will say that there are 900 files in this directory. And so we saw very briefly, I got rid of it, so let's look at it again, that each file, starting with a sample and then a number, there are 3 types of files. There's a .fq, .tsv, and .txt. And so we know what these files are. A .txt is a plain text file. A .tsv is a plain tab separated value file. And then a .fq is a file type commonly, or file extension commonly used to denote that this is a FASTQ formatted file, which is a biological file that stores DNA information, and it stores sequence information along with quality information. Okay, and so as part of the practice, we're gonna tackle this question right here. So we're assuming, and it might be wrong to assume, but let's assume that there are 900 files in 3 file types, and that we might expect that there are 300 of each of these file types. But we can't be sure until to check that. So from using what we've seen, how can we count how many files there are of each file type? Okay, so before I click the solution button, let's think about what we have available to us. So we know that we can list the files that are present here using ls. We know that there are a number of files that have shared extensions, right? So components of their file name that they all share, but other files don't share. We learned how to use the wildcard, and then we also learned how we can pipe that information that we get from ls into word count -l to count how many of something there are, right? So okay, roughly that should work. So we can do ls *.txt, and then we're going to pipe that to word count -l for the line and hit enter. Okay, so there are 300 files of that. I can retype this out and put in the next file extension that we want to work with, .tsv, pipe it to word count -line, hit enter. Another 300. Okay, we're getting there. It seems like it would be 300, 300, 300. The other thing that I can do, so instead of retyping all this out, I can hit the up button, which will bring up our last command, and I can move my cursor over, delete the specific extension that we just looked at, and replace it with FQ, and that's that. So it's 300, 300, 300, 300. Great. So we have all of the, we know that there are 1 for each of the sample types here, and that there's 300 of each type. So one of the things that's interesting about this is that if we did this, right? So let me show you. There's a couple ways we can string this together. This is not part of the tutorial. Sorry, Mike, but this is for the folks at home. There's a couple ways we can play around with this and see this and see these examples in a couple of different ways, right? So before I did ls or pipe to word count -l, that told us there were 900 files there. So we can also do something like this. This is pretty fun. We can do ls pipe to head, and that should give us ls and then the first 10 outputs of that. Okay, and that's what it did. And so you can see there are 3 of each of these files. So we got 3 sets of 3, and then the first of the 4th number. As you can see, the formatting of all of this has sample underscore a number and then this information here. So if we were to do ls sample, and so we can do this using the tab autocomplete. So if I did ls s, hit tab, it says, okay, there are a bunch of files here. A bunch of them start with an S, and actually if you autocomplete it, it's ample to an underscore. Now if I hit asterisk, it's the opposite of what we were just looking at, where we were looking for things that shared an extension. Now we're looking at things that share a prefix, the prefix being sample underscore. And then we can pipe that to word count dash line, and this should function exactly the same way as ls pipe word count dash l, because all of the files have that formatting of sample underscore something. And we get 900. So there are other ways, obviously other ways that we can take these components and mix and match them in ways that replicate not only things that we would expect from raw commands, but also to interact with ways that we would want to maybe look at other information. And so I'll click the solution here. That should be what we did up here. That's great. Oh, so nice. It's nice when it works. All right. So we've used the asterisk, we've used the ls command. We can use it with other Unix commands, right? So here what we're gonna do is move. And so from lesson 2, we learned that move physically, or virtually in this instance, virtually destroys a file and then moves it to a new location, right? So what we're gonna try and do here is we're gonna take all of those .fq files and we're gonna move them using information from lesson 2 into a new directory. So we got to do a couple of things here, right? So the first one is redo this command ls.wordCount, pipe to word count, where there are 900 files. We're going to make a directory. So we're going to do make directory. We're going to call it fastq underscore files. And now we can look into that directory like that and see that it's empty. That's good because we just made it. We wouldn't want it to be full. So we know that if we do ls dot or asterisk dot fq, if I hit enter here, it's going to produce 100 fq files that are in this directory with us. And now if I do move asterisk dot fq into fastaq files, so what I've done is I've used the move command. I've taken all of these files here and I've virtually moved them from where we are into this new directory. And so now we can do this in a couple ways. We can look at ls. One of the things is if we just hit the up button and look at ls.f, if we hit the up button twice, we can see ls.*fq. If we hit enter, because we just literally moved these from our directory that we're in now to a new directory, they shouldn't be there anymore. So when we hit enter, it says there's nothing here. There's nothing that matches asterisk.fq. And that's the reason is because we put them somewhere else. And so we can, again, we can use ls. In this case, I'll use ls pipe to head just to print out the first 10 lines. You can see now in our directory, there is this directory that we called fastq underscore files. We still have that same formatting, sample underscore 100, but instead of having an fq file, it's just the tsv and the txt files. If we do ls of the new directory that we made, fastq underscore files, and hit enter, we're going to get all 100 of those files printed there again. And so we can do two different things here. We can do ls pipe to word count. And so we would expect the number that was originally here, 900, to be reduced. It should be reduced by 300, but when we hit enter, we'll see that it says 301. Okay, why does it say 301, do we think? If you're reading along, there's a solution to that. The reason it says 601 is because ls is reading everything that's in the directory. So we have the 900 minus 300 files plus the new directory that we just created. That's why it's at 601. So we can do a couple of things here. That's the solution. Yep. So we can do a number of things that aren't, again, in just for the folks at home. So we can ask things like ls. Let me clear some of this space up here. We can do ls fastq files star, right? So this is going to say ls and give me, we can do star.fq, pipe it to word count. And so this should give us that 300 number. Great. We can do it ls fastq word count because the only files in there end in .fq. should also be 300. Great. We can work with the files that remain in the directory that we're in, this all samples directory. And we can do something like this. We can say, okay, we don't want you to count that directory, but we know all the files are named sample. So we've done this before. We can do sample with an asterisk. And that says there's 600 of those now, right? Getting rid of that one. We can also do, and this would be a fun little thing, is we can do ls, we can say asterisk dot, and we did this before with txt, so that just captures all of the txt files. And if I do it again with tsv, it captures all of the tsv files. But if I use 2 asterisks, getting crazy here, to the parts that are shared between these files, which is the T. So now we're looking for anything, any file in this whole directory that has anywhere in it a period T, right? And so this should capture everything that has before the period, so all that sample information, and then either TXT or TSV, so it should add our 300s together, and there are now 600 of them. Great. So that's how we would work with wildcards. That's how we work with, well, there's another wildcard that we're gonna get to. We're gonna talk about this history first before we get to the last wildcard of the day. But those are alternate ways that we can work with those commands. Okay, so let's talk a little bit about, very quickly, history. So history is a command that will print out all of the commands that you've run on the most recent terminal encounter that you've started. So if I did history right now, it would print out all of the information from lessons 1 and 2, because I'm recording that sequentially, which might be a little overwhelming. You don't have to do this. I'm gonna do it. Let's live on the wild side a little bit. I'm gonna hit history. And you'll just see, so since the beginning of this tutorial, there have been 136 commands that have been run. And so we can pipe history into all the other tools that we've learned so far today, including, so if I clear this information, I can do history piped to tail, and that'll give us the last 10 commands that I've run, which includes now history and clear. I can do history into less, and that will let me browse through the commands that I've looked at already. So these are the ones that we've done from the last couple sessions all the way down to the end. So if we're at the end, you can see the last one I run was history tail, and the most recent one is now history less. To get out of less, we can hit Q, and we escape out. So yeah, so there are a lot of ways that we can interact all this information. So if we get to this quick practice right here that Mike has laid out for us, we've done it once with the .fqs. We can do it with the other types of file types that we have too. So this says create separate directories for the .txt files, the .tsvs files, and then move them into their correct directories. And so to some degree, the names don't matter, but let's try and keep it similar in the same vein that the fastq files were, right? So if we do ls head, we called it fastq files. So we can make a directory where we say this is going to be called the text files, not the X files, but the text files. We can make another directory right now that we're going to call tab files. And then we can use our move command with the wildcard. So here we're going to use txt. We're going to say go into text files. We're going to move them all there. And then we could do it again, but this time we're using the TSV. Put the period in there. Put it in the tab files directory. Take a second. Okay, there you go. And now what we've done is we've taken that original 900 files, which were just in one directory, 900 files, one of each type of the suffixes for the file types. And now we've moved them all into their own directories where we can find them in the future. So if we hit ls, instead of any text files being present at all, we just have 3 directories, and each one now stores 100 files of the suffix that we were working with before, the extension that we were working with before. Okay, so the last thing that we're going to do today is we are going to play around with the other wildcard that was introduced at the beginning of the lesson, which is question mark. So asterisk will look for everything that is part of between two elements, right? Doesn't matter how many spaces there are, doesn't matter how many letters there are, doesn't matter the type of characters, it will find everything between the start and the end of where you put this. And we'll use this example very specifically. Question mark functions differently. So if we cd into FASTQ files and we hit ls, and in this case, we're going to do sample, we're going to put a 1 here. And so if we wanted to know right now how many options there actually are from sample_1, we could hit double tap quickly here. Our goal is to capture the numbers 10 to 19. So if we do that, if I do a quick double tap, it's going to say, are you sure you want to see all 111 possibilities? Because it's going to print it out to the screen. And you're going, okay, but I only want 10 to 19, right? So that's only 10 numbers. Why am I capturing a bunch of extra stuff? And it's because of the way the asterisk's functioning, right? So it's not just capturing 1 and then 1 space here before the FQ. It can count all spaces, including the hundreds. So if I hit yes, it prints out. You can see not only am I capturing 10 through 19, but I'm also capturing 1 because asterisk counts 0. But I'm also capturing all the numbers in the hundreds digit that start with 1. And if there were thousands, I would capture all the thousands. If there were 10,000s, I would capture all the 10,000s, which would become pretty problematic for us. So I'm going to do ls star.fq. It'll print the same information and not just the tab information. So if we're interested in grabbing just things that have exactly 1 element to it, we can do ls sample_1 question mark .fq. And this now takes into consideration that spacing information between the 1 and the period, right? So we're only looking for all options that are exactly 1 character long. And then we get the 10 documents that we were hoping for right there. And so it's just a way that we can work with. So there are multiple wildcards. So that way that we can target specifically the files that we want from a larger subset that we're working with. And so just to summarize this lesson, we learned a very few extra commands here, but we did learn a lot of the key characters that are part of Unix, including the pipe, which allows us to string multiple commands along. In all the demonstrations I used, I only used pipe once, but you can pipe multiple commands together at one time. And we'll talk about that more in the next couple of lessons. We talked about sending your output that normally prints to a screen to a new file using the caret. We talked about how you could do the same thing, but append it to an existing file using the double caret. We talked about the wildcard asterisk and the wildcard question mark, which captures any number of characters between the information that we're asking it to look for. And in this situation, just 1 characters are appearing exactly 1 time. So with that, I'm going to conclude lesson 3. We'll continue with lesson 4, which is titled by Mike, 6 Glorious Commands. The 6 commands that you should learn and know when you're working in the Unix environment. See you in the next lesson.